Alright, good day to you. So today we're going to continue with chapter 6.2. Chapter 6.1, we are still on the electric circuit. We are going to continue with 6.2. We have talked about electric current. We talked about voltage in the last few lessons. Today we are looking at resistance. So resistance is how much a component opposes the flow of the current through it. It causes the electrons to bump into each other. Alright, so resistance is how much a component opposes the flow of the current through, which means that the greater the amount of resistance, the lower the amount of current along the circuit. So moving on to the next slide. So it says here a high resistance means that it's difficult for current to pass through the material. Why? Because if you have more electrons that are bumping into one another, as you can see in this diagram, it means that it's harder for the circuit or for the current to flow through the material, which means that there's a greater resistance. If I move on to the next slide here, it says a low resistance means that it's easier for the current to pass through the material. So along the circuit here, you can see that there's lesser electrons bumping into one another. Because there's lesser electrons bumping into one another, there's lower resistance because it's easier for the current to pass through the material. Move on to the next slide here. This is every time electrons bump into each other, they lose a little bit of energy. This results in the loss of energy as the current flows through a circuit component. This energy loss is known as voltage drop. If you still recall what we have discussed in the last few lessons, we say that when the circuit is moving through a light globe, in addition to light globe lighting up and releasing heat, we know that there's a drop of the voltage. Because of that voltage drop, it enables the light globe to power and to release heat. So what it's trying to say is that when electrons are bumping into each other, that will result in loss of energy because the current that is flowing through the circuit, it has flows through the light globe, and in order to power the light globe, it will result in this voltage drop. So we're on to the next slide here. So it says here a component with high resistance have a large voltage drop. You probably will agree with me on this. It says this means it loses loss of energy. It's because the electrons bump into each other a lot in components with high resistance. There is a small voltage drop across a component with low resistance. The component loses less energy than a component with high resistance. It says this is because there are fewer electron collisions in components with low resistance. So what it's trying to say is that in a component with high resistance, it will have large voltage drop because it will lose a lot of energy. Alright, because it loses a lot of energy to the light globe itself. When there's a small voltage drop, it will result in a low resistance. It means that that component is losing lesser energy because of fewer electron collision. The same goes for if you have a lot of electrons that are colliding or bumping against each other, most likely you get a large voltage drop, which means that you have a greater amount of resistance. But if you have lesser electrons bumping into each other, you have a lesser or smaller voltage drop, which means resistance will be a lot smaller as well. Moving on to the next slide. Alright, so there are some factors, there are a few factors that can affect the resistance of a wire. See, the resistance of a wire depends on the type of material the wire is made from. Say, for example, metals generally have low resistance, whereas rubber has high resistance. So in this case, if the material is highly conductive, most likely it will have a lower resistance. If the metal is less conductive, it will have high resistance, which is harder for the current to move through the circuit. So you see length of the wire, doubling the length of the wire doubles the number of obstacles that the electron must pass through. This doubles the resistance. Thickness of the wire is more difficult for electron to pass along thin wires than to pass along thick wires. Alright, so in general, the resistance will depend on the type of materials. If the material is highly conductive, it will have low resistance. Material that is not very conductive, it will have high resistance. Length of the wire. The longer the length of the wire, the more time that the electrons need to spend on the circuit, which means that the greater the amount of resistance. Thickness of wire. It is more difficult for electron to pass along a thin wire than to pass along thick wire. So the thicker the wire, the lesser the resistance. If a thin wire means the electron have to be squeezed in that particular circuit itself, there will be more collision between the electrons, there will be more bumping between the electrons, which means it's harder for the electrons to pass through the circuit. Moving on to the next slide. Alright, resistors. Resistors are components that are non-resistant. They are used to restrict the current flowing through them and the components in the rest of the circuit. Is that variable resistor allow you to change the resistor, and so they can be used to control the voltage and current flowing through the component in a circuit. In this way, they can control the speed of motor, the brightness of the globe, and the volume of the speaker. Is as such, variable resistors are commonly used in dimmer switches and to control radio and TV volume, the speed of air conditioner fans, and car windscreen wipers. So resistors here, they say are components that have known resistance. So it says that they are used to restrict the current flowing through them and the components in the rest of the circuit. It allows you to change the resistance so that you're able to control the voltage and current flow. So then again, if you go out, if you go to Bunning today, you probably can buy specific resistors, and each of them will have a different resistor. If I have more time during our lesson, I will explain to you more about these different type of resistance, but in general, different resistors will have different resistance, and they do control the voltage and electric current that is flowing along the circuit itself. And usually you'll find these to control radio, TV, volume, speed of air conditioner fans, car windscreen wipers, and other examples, as well as other electronics that you can probably find. So move on to the next slide. So conductors, metals are conductors. So we talk about if that material is highly conducting, most likely you have a very low resistance. So it means that electric current will pass easily through them. However, some metals are better conductors than others, depends on their resistance. So copper is an excellent conductor. It's a very low resistance and almost no energy is lost from it. It is also relatively cheap. For these reasons, copper wires are used in most electric circuits around the home, in factories, and in cars. You see, another excellent low resistance conductor is aluminum. Aluminum is more expensive than copper, but also much lighter, which is why aluminum is used in high voltage transmission lines shown between distant pylons. Because you're talking about those pylons, those huge pylons that you probably can find in some of the suburbs, you need the wire to be highly conductive. You do not want it to have high resistance, because then the electric circuits will flow very slowly along that particular circuit. In this case, which is why they are making a comparison between copper and aluminum. They know aluminum, even though it's more expensive, but it's lighter and is highly conductive, because it has a very low resistance, which is why they then prefer to use aluminum instead of copper for these high voltage transmission lines. They are shown between distant pylons. So moving on to the next slide, which is the last slide for this particular spread. Conductors with higher resistance. So it says tungsten and nickel alloy are metals too. They also conduct electricity, but not as well as copper or aluminum. The tungsten and nickel have relatively high resistance, and so electrons passing through them lose much of their energy and voltage. They say this energy is converted into heat and sometimes light. This makes them ideal to use as heating elements in electric kettles, hair dryers, electric blankets, and filaments of old-fashioned incandescent light globes. So what they're trying to say here is that you have some metals that are not as conductive as what we have discussed previously, copper and aluminum, but we have something like tungsten or nickel. They have higher resistance, and what they do is that because they have higher resistance, means they have a greater voltage drop. They are very good in lighting up some of these heating elements, because they produce a lot of heat. They do produce that, but they produce heat as well, and that's what we want in electric kettles, hair wires, hair dryers, electric blankets, filaments of old-fashioned incandescent light globes. So not very conductive, still conductive, not as conductive as copper and aluminum, but perfect because they have a greater resistance, they have a greater voltage drop, and they are good for these heating elements in different electronic equipments. Alright, so make sure you do complete all the questions. There is a particular website that I need to use for this lesson as well, and there's an experiment I need to try as well. So do check that out, and then I'll discuss more with you on class. So check it out. All of this information are on Schoolbox. So check it out, and I'll discuss with you in class.